Today's lesson is on adding and subtracting algebraic fractions. First, I want to do a very quick recap of adding and subtracting numeric fractions. So, for example, if we had 2/3 plus 3/4, we can't just add those together. We need the fractions to have the same denominator before we can add them together. So, these two numbers do not have any common factors, which means I'm going to multiply this first fraction by 4, both the numerator and the denominator, and I'm going to multiply this fraction by 3, both the numerator and the denominator. That means I end up with 8/12 as my equivalent fraction for 2/3 and 9/12 as my equivalent fraction for 3/4. Now, because the denominators are the same, I can just add the two numerators together. So I get 17/12. I can leave it like that, or I can write it as a mixed number, 1 and 5/12. And it would be exactly the same if I was subtracting. So if this was a subtraction sign here, I would still do the same method. I would still turn them into equivalent fractions over the same denominator, and then I would subtract the numerators instead. I wouldn't always need to just multiply by the alternative denominator. I look for the lowest common multiple of the two denominators. So here we've got 15 and 10. Both of those go into 30 quite easily, which is going to be nicer than making a denominator of 150 by multiplying these two together. So 30 is a common multiple of 10 and 15. So for this one, I'd multiply by 2/2. For this one, I'd multiply by 3/3. So I'd have 14/30 plus 12/30. So I would have 26/30, which I can simplify to 13/15. That is enough information for you to have a go at the starter. So have a go at question 1 and question 2, please, and then mark your answers. So pause the video here, have a go at those starter questions, and then come back for the rest. Okay, so the main part of the lesson is adding and subtracting algebraic fractions. We use exactly the same method as we use for numeric fractions. So for our first example, x minus 2/3 plus 2x plus 3/4. Just like with the numeric fractions, we need to turn these two fractions into equivalent fractions so that they have the same denominator. So for this one, I'm going to multiply by 4. And then for this one, I'm going to multiply by 3. So they now both have a denominator of 12. I can multiply these brackets out. And just put both over their common denominator. So it's now over one denominator. It is now one fraction. Then I collect like terms in the numerator. So I've got 4x plus 6x, so I've got 10x. And then I've got -8 plus 9, so I've got +1. And that's my final answer. So exactly the same method as with numeric fractions. Make the denominators the same, put them as one fraction, and then simplify where possible, which we've done by collecting like terms. That is enough information to have a go at exercise 2, questions 1 and 2, but you need another example to be able to do question 3. So you can either pause here and have a go at 1 and 2 now, or look at the next example and then have a go at the whole of exercise 2. Okay, so our next example, 2x minus 1 over x plus 1 minus 3 over x minus 2, and we want to write this as a single fraction. We want to put them over a common denominator, so we're going to do exactly the same as last time. I'm going to multiply this one, top and bottom, by this denominator, and I'm going to multiply this one, top and bottom, by this denominator. So what I'm going to end up with is 2x minus 1 times x minus 2, and that's over x plus 1 times x minus 2. And then I'm going to subtract 3, and this time I'm multiplying this by this denominator, so 3x plus 1 over x minus 2, x plus 1. And you can see the denominators are the same. The brackets are not in the same order, but multiplication is commutative, so we could swap them round. They have the same denominator. So if I put this over one denominator, I will have 2x minus 1, x minus 2, minus 3, x plus 1, all over x plus 1, x minus 2. So this was where we'd got to. The next step is to multiply out this top bit. So I'm going to have 2x squared minus x minus 4x plus 2. Then here, be careful with the sign, I'm going to have minus 3x minus 3 times 1, so it gives us minus 3. And on the bottom, I'm going to have x plus 1, x minus 2. I don't need to multiply that out. The reason I've multiplied the top out is so that I can collect like terms and simplify. So if I collect like terms, I'm going to have 2x squared. I'm going to have minus 8x. And I'm going to have minus 1 all over x plus 1, x minus 2. The top doesn't factorise easily, so I'm going to leave it as it is. That is the final answer, and you now are able to do question 3 from exercise 2 as well. Final example. This is similar to the second numeric fraction example that we did. The first fraction has a quadratic as its denominator, and the second fraction just has a linear term. Now what we want to do first is check whether these have any common factors. So this one, I can factorise the bottom as a quadratic. It is x plus 1, x plus 2. What that means is they both have x plus 2 in the denominator. So instead of multiplying this fraction's numerator and denominator by x squared plus 3x plus 2, which would turn both of these into cubics and make it quite difficult, I only actually need to multiply this one by x plus 1. So this fraction stays the same. This fraction, I multiply top and bottom by x plus 1. And now both fractions have the same denominator. So I didn't need to multiply the two denominators together. I just needed to identify what extra factor I needed to multiply by to get them over the same denominator, and that's where I've got to. From here, I don't need to multiply out the bottom. I do need to multiply out the top and put it over the one denominator so that I can collect like terms and simplify. So I've got x, and multiply this out. X squared plus x minus x, and then minus 1. And that's all over x plus 1, x plus 2. Because this is a quadratic, I'm just going to rearrange it so that the x squared term comes first, because that's convention, but it doesn't really matter. And again, the top does not factorise nicely, so I'm just going to leave it like this, and that is everything you need to do the rest of the questions. So have a go at those. If you get stuck on any, please let me know, and then mark your answers once you've finished.